Hello everyone. Now we will dive into an exciting area of machine learning called reinforcement learning. This technique is all about how an agent learns to make the right decisions by interacting with its environment. By the end of this session, you will understand how reinforcement learning works, its applications, and its advantages and challenges. So let's get started. What is reinforcement learning? Reinforcement learning, or RL, is a type of machine learning where an agent learns by trial and error. The agent interacts with an environment and receives feedback in the form of rewards for good actions or penalties for bad ones. The goal of the agent is to maximize its total rewards over time. For example, think of training a puppy to sit. When the puppy sits correctly, you give it a treat, that is a reward. If it does not sit, there is no treat, that is no reward. Over the time, the puppy learns that sitting earns a treat, so it keeps sitting more often. This feedback helps it improve with each attempt. This is reinforcement learning in action. Now let's discuss the key concepts in reinforcement learning. Reinforcement learning has a few key building blocks. First is agent, which is the decision maker or learner. Next is environment. The world in which the agent operates is called the environment. Next is actions. This is the choices the agent can make. Next is reward, which is feedback signals that tell the agent if its actions are good or bad. Next is state, which is the current situation the agent is in. And finally, policy, which is the strategy the agent uses to decide its actions. All these elements work together to guide the agent's learning process. So, how reinforcement learning works? Here is how the reinforcement learning process works step by step. First, the agent starts by observing the current state or its environment. Second is, based on this observation, it chooses an action using its policy. Third step is, the environment responds to the action, providing feedback in the form of a reward or penalty. Next, the agent uses this feedback to improve its policy, learning which actions are most beneficial. This cycle continues until the agent learns the best possible behavior for maximizing rewards. What are the common algorithms used in reinforcement learning? There are several algorithms in reinforcement learning, each suited for specific tasks. Like Q learning, this algorithm learns the value of taking specific actions in specific states. Deep Q networks or DQN. This combines Q learning with deep learning to handle complex problems like video games. Policy gradient methods. These algorithms learn policies directly, focusing on improving the agent's decision making strategy. Next is actor critic methods. This is a hybrid approach that combines value based and policy based methods for faster learning. These algorithms make reinforcement learning versatile and powerful. Now, let's discuss some real world applications of reinforcement learning. Reinforcement learning has numerous applications in real life. For example, gaming. It is used to train AI agents that can master games like chess, Go, or complex video games. Next one is robotics. Robots can learn to walk, pick up objects, or even perform surgeries using reinforcement learning. Next application is self driving cars. Reinforcement learning helps cars learn to navigate traffic and make real time decisions. Next is finance. It is used to optimize stock trading strategies and manage portfolios. These examples show how reinforcement learning bridges theory and practical use. Now let's discuss about its advantages and limitations. Like every technology, reinforcement learning has its strengths and weaknesses. Let's discuss advantages first. It is highly adaptive and can excel in dynamic, ever changing environments. It learns directly from trial and error without needing labeled data. Limitations. It can require significant time and computational resources to train. Sometimes the learning process can be unstable, specifically in complex environments. Despite these challenges, its benefits make it crucial area of machine learning research. To summarize, reinforcement learning is all about teaching agents to learn through rewards and penalties in a feedback loop. We have covered its core concepts, how it works, key algorithms, real world applications, and its pros and cons. It is fascinating and evolving field with endless potential. Thank you for your attention. I would be happy to answer any questions that you may have in the comment section.